S equals R times theta. And then we're going to label some of this stuff. All right, the S, even though it's an S, doesn't always make sense. That really is the arc length. So they let S denote arc length. R, like always, is radius. So at least that's familiar. Okay, now, as far as units, you're going to have to label this stuff. All right, the arc length and the radius is going to be in the same label. So if I tell you the radius is in inches, your arc length is going to be in inches. If your arc length is in feet, your radius is going to be in feet. All right, so let's put same unit. Okay, now the theta is the central angle. We've already looked at a central angle today. It's got that vertex at the origin. Okay, it goes out. Now, this is the part that everyone forgets, so I'm going to go even yet a different color here. Now, I'll just stick with my purple. Your central angle must be in radians. If I want to use this formula and figure out what the arc length is, then whatever my angle is, whatever the theta is, I've got to make sure it's in radians. So if they give it to me in degrees, I have to convert it to radians first and then plug it in the formula. If they give it to me in radians, life is easy. Okay. All right. So let's throw an example on here. I'm just going to make one up here. Oh, that would be an easy one. Now let's do this one. Let's say it's like find the radius. Let's say that's our directions. Find the radius. And let's say that they tell you the arc length. Well, I'm not going to know that this is going to work out nice. I'm going to make this up, so I won't, because I want to do a certain thing here. So I don't know that this is going to be nice. Let's say the arc length is, let's pick all even numbers and hope the math works out. Let's say it's, let's go 10 inches. And then let's say that the theta is 60 degrees. So find R. What's R? What's the radius? Arc length is 10. My central angle is 60 degrees. What's the radius? Okay. Now, first off, I've got to take that 60 degrees and turn it into radians, because this formula, if I want to use this formula, I have to have radians. Okay. So let me go to yet another color. Let's pull out a red here. Okay. So step one. Okay. So I'm going to take 60 degrees over 1. I'm going to multiply by what? Pi radians over the 180 degrees. Okay. Degrees crosses out. Have we already done 60 degrees? Yeah, we did. That was the first one we did, right? So we do that. 60 pi over 180 reduces down to what, pi over 3. So this is pi over 3 radians. So I've got my conversion. I'm in radians now. So instead of this, I'm going to use pi over 3 radians for my central angle. Okay? Because I'm telling you right there, that's the number one mistake. You're going to apply this formula with 60 and 10, and then you're going to miss the problem. Okay? All right. Step 2. All right. Use our formula. Capital S equals R theta. S is 10. I'm trying to find R. I know theta is pi over 3. Okay, can I solve for R? Yep, so multiply by the reciprocal. Don't let me screw up. So this is going to be like 30 over pi equals R. Okay, so yes, weird number because I just randomly made this stuff up. All right, what's the label? Inches, because your arc length and your radius is going to be in the same thing. And if I wanted to convert that to a decimal, I could. All right, I don't know, I got a calculator real handy. I could do this. 30 divided by pi So R is going to be approximately 9.549 inches. If they give you the central angle in radians, a lot faster, because then you just plug it into that little formula and then you do it. So I did a harder question than as opposed to a straightforward question.